Hypertrophic cardiomyopathy, or HCM, is the most common genetic cardiomyopathy, affecting up to 1 in 500 individuals. Despite advances in the genetics of HCM, a causative pathogenic variant is detected in only about 40% of individuals using standard panel-based sequencing approaches. The standard approach includes amplification and sequencing of exons and flanking intronic splice site junctions. However, this method fails to identify deep intronic variants that may cause aberrant splicing. Transcriptome sequencing can address this gap, but it requires mRNA from relevant tissue, which is a significant barrier for cardiomyopathy genes. Holliday and colleagues at the University of Sydney address this issue using human-induced pluripotent stem cell-derived cardiomyocytes, or HIPSC-CMs, derived from 3 unrelated patients with HCM. As compared with controls, they confirmed the presence of aberrantly spliced exon 14A in MYBPC3, caused by a splice acceptor site gained through the C1224-52G to A variant. In the second patient, they confirmed the presence of aberrantly spliced exon 12A in MYBPC3, caused by a spliced donor site gained through the C1090+453C to T variant. Finally, in the third patient, they observed aberrantly spliced exon 20A in MYBPC3, caused by a novel spliced donor site gained through a C1928-569G to T variant. This novel variant was also observed in myomectomy tissue from the patient's sister ID2. The variants in all 3 patients lead to a frameshift and subsequent premature stop codon. Finally, the authors showed that antisense oligonucleotide treatment could suppress aberrant splicing in the second patient's HIPSC-CMs. Transcriptomic sequencing of patient-specific HIPSC-CMs is labor-intensive, but it represents a highly informative adjunct test for cardiomyopathy in patients whose standard testing does not reveal the genetic diagnosis.